continuing from our derivations on the temperature difference for the 5 different sections, then we can now add these 5 equations to obtain temperature difference from fluid A to fluid B. So basically we are just adding the one on the region 01. Okay, in the region 01 we have these expressions in here. We are adding it with the region 1, 2, and then region 2, 3, plus the one on the surface 0 or the innermost surface, and then the surface 3 or the one on the outermost surface. So if we do so, we add, then we will have TA minus T naught plus T naught minus T1 plus T1 minus T2 plus T2 minus T3 plus T3 minus TB is equal Q naught 1 over H naught plus R naught K01 ln R1 divided by R naught plus R naught divided by K12 ln R2 divided by R1 plus R naught divided by K23 ln R3 divided by R2 plus R naught divided by H3 R3. And the temperatures in here can be cancelled, so that you basically have this TA minus TB equal to R naught Q naught RO HO plus run R1 divided by R naught divided by K01 plus ln R2 divided by R1 divided by K12 plus ln R3 over R2 divided by K23 plus 1 over R3 H3. So once we have these things, then we can also find the heat flow, which we define in here as the capital Q naught in joule per second. So the Q naught in here will be equal to pi L R naught Q naught. Okay, a particular emphasis is given in here so that you can have a the form recognized. This one should be 2 pi L TA minus TB, and this one will be equal to 1 over H naught ln R1 R naught divided by K01 plus ln R2 over R1 divided by K12 plus ln R3 R2 divided by K23 plus 1 R3 H3. And then with this, then the overall heat transfer coefficient can be defined based on the inner surface. U not. That's why 0, the not in here is basically referring to the inner surface. Okay, so that this Q naught will be equal to 2 pi L R naught Q naught, and that will be equal to U naught 2 pi L R naught TA minus TB. Then we can equalize the terms. So that we have basically U naught R naught equal to 1 divided by 1 over R naught H naught plus ln R1 R naught divided by K01 plus ln R2 R1 divided by K12 plus ln R3 divided by R2 divided by K23 plus 1 divided by R3 H3, and so we will have 1 over R naught U naught will be equal to 1 over R naught H naught plus ln R1 over R naught K01 plus ln R2 over R1 divided by K12 plus ln R3 over R2 divided by K23 plus 1 divided by R3 H3. Okay, so then finally we can write the generalized expression. 1 over R naught U naught will be equal to 1 divided by R naught H naught plus sigma from J until 1 until N, where N in here indicates how many different cylindrical walls that you have within your composite cylindrical pipes, divided by K J minus 1 J plus 1 over Rn Hn. Okay, so this is what we call the generalized formula for a system with n annular layers. Okay, the important things in here is that you notice that the subscript not in here on U naught indicates that the overall heat transfer coefficient is referred to the radius R naught. So unlike in the previous case where we have basically flat walls that doesn't have a curve effect, the difference comes into the preserved quantity, which in this case the one that is preserved is basically the product between the between the R and the heat flux. Okay, so in here it's very important to notice that in here this only the product of the Rn and the heat flux, whereas before the heat flux itself, because there is no curvature effect, so the heat flux is the one that is conserved basically. Okay, then this has an effect into the overall heat transfer coefficient. Your overall heat transfer coefficient in here, the expression comes with reference, so it has to be referred with respect to the particular surface. Okay, with that I conclude the video for this example. Thank you for listening.